Good morning, children. So now let us see question number 7 from exercise 4.1, and here find the value of determinant. So this determinant is given. So we write let delta equal to this x plus lambda. So here we have to use property of determinants. Right now if you see, you won't find anything common in either row or column, but if I operate this, operating this first column becomes C1 plus C2 plus C3. If this operation is done, okay, then we will get, see this x will add, this x will add, so altogether you will get 3x plus lambda. Same thing over here, 3x plus lambda, 3x plus lambda. Since second and third column they are not being operated, so you have to copy as it is. So here you get this is done. Now from the first column you will take this out common, 3x plus lambda. So you are left with 1 x plus lambda x plus lambda. And once you see like in any row or a column that all the elements are 1, then try to make 2 of them 0. Okay, so here what I will do, I'll try to make this 0 and this one 0. So for that what I can do is I will write operating row 2 minus row 1, row 3 will be row 3 minus row 1. Okay, so we will get 1 x and here we'll get 0 lambda 0 lambda. Okay, so what is happening, first column you can see that 2 elements are 0, so we will expand along. Oh, we had this 3x plus lambda common outside. Now what we'll do, we will expand along first column. So expand it along first column. You remember plus minus plus minus plus minus plus minus plus. So for the first column you have to use this. Here these two are 0, so we have to only deal with this one, and we have to put plus sign before it. So already plus, so no problem. Now we'll cover this row and this column. We are left with lambda 0 here. Got it? Now 3x plus lambda. Now you find the determinant, you get lambda square minus 0, which is equal to lambda square 3x plus lambda. Okay, so this is your answer. Now let us see question number 2. So we will write let delta be equal to this 0 a square b a square c ab square 0 b square c ac square bc square 0. Here you can observe one thing, that in the first column we have a square common, okay, because here we can write a square into 0, okay, and here a square into b, a square into c. Here you can see in the second, you see that b square is common, okay, and in third c square is common. So we will take out a square common from the first column, so we get a square. From second we are taking out b square, and from third we are taking out c square. So we are left with 0 b c a 0 c a b 0. Now again you will observe one thing over here, that in the first row we have a common because 0 into a we can write. In second b is common because we can write 0 into b. In third c is common because we can write 0 into c. So we will take out a common from the first, b from second, c from third. So when this a comes out with this a square, it will become a cube, this will become b cube, this will be c cube. Now you are left with 0 1 1 1 0 1 1 1 0, okay. There is one property which says that if okay, now what we'll do is we'll try to make this like one of them 0, okay, like here you can see that here 1, here also 1. So let's do one thing, operating row 2, okay, we can do this. So now what will happen, we get a cube, b cube, c cube, okay, and 0 1 1, here we'll get 0 because this one minus this one, okay, and minus 1 1 1 1 0. Now let us expand along the first column. So here for the first column we have plus minus plus, okay. So a cube, b cube, c cube, 1 into, now forget this column, forget this row, you are left with 1 1 minus 1 1. So here we are getting a cube, b cube, c cube, and here 1 minus minus 1. So we are getting 2 times a cube, b cube, c cube, okay. So this is your answer for your 7 2, okay. Now let us see question number 3. So let delta be equal to this: x square plus y square plus 1, x square plus 2y square plus 3, x square plus 2y square plus 6, 3y square plus 8, y square plus 1, 2y square plus 3, 3y square plus 4. So this is your delta. Now here we don't see anything common right now, okay, but you observe one thing, that this is y square plus 1, and here we have y square plus 1. Here we have 2y square plus 3, here we have 2y square plus 3, here 3y square plus 4, here we have 3y square plus 4. So if I operate this, that r1 becomes this r1 minus r3. So in that case, what will happen? This will be removed. Yes, in the next step. And you can see that x square will be common. Yes. So let us do that. So operating R1 becomes this. So we will get x square, x square, x square. Here y square plus 2, 2y square plus 6, 3y square plus 8, y square plus 1, 2y square plus 3, 3y square plus 4. Done till here. X square is common from the first row, so you got that. Now 1, 1, 1, y square plus 2, 2y square plus 6, 3y square plus 8, y square plus 1, 2y square plus 3, and 3y square plus 4. Next, what we can do is, here we see that here we have y square, here also y square, 2y square, 2y square, 3y square, 3y square. So either from the second or third we can remove y square. Okay, so let's do one thing. We'll write operating R2 minus R3. So I'm going to remove y square, okay, this y term from second row. So that way I'll get x square, and here 1, 1, 1, and here simply this y square cancel, and 2 minus 1 simply 1. Here we'll get 3, here we'll get 4. Here we have this y square plus 1, 2y square plus 3, 3y square plus this. Now in the next step what I will do is, here you can see that in the third row we have that each element is sum of two numbers. So I can write like this, x square, and this single determinant, okay, this can be written as sum of two determinants. One, 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 1, 3, 4, 1, 3, 4. But once I write as sum of two determinants, this will become 0. The reason is this row 2 and this row 3, they are equal. Okay, so I am getting this x square 1, 1, 1, 1, 3, 4, y square, 2y square, 3y square. Okay, now from the third row I will get y square common. So x square into y square, 1, 1, 1, 1, 3, 4, 1, 2, 3. Okay, so here you see that in the first row all the elements are 1, so we can make two of them can be made 0. Okay, so right, operating C2 minus C1, C3 tends to C3 minus C1. So what we are getting, x square, y square, okay, 1, 1, 1, 0, 3 minus 1 2, 2 minus 1 1, 0, 4 minus 1 3, 3 minus 1 2. Now expand along first row, so you get x square into y square, 4 minus 3, so x square into y square. Okay, this is the answer. Okay, now let us see question number 4. So let delta be the given determinant. Done. So again, just by looking at it, I'm not able to see anything common, but I see that if this operation is done, okay, so when second row will be added to this will become 2, okay, and then again this third will be added, this will become 3 minus lambda. In this case, minus 1 plus 5 minus lambda, okay, and plus minus 1, you will be getting 3 minus lambda. Here also 1 plus minus 1 plus 3 minus lambda, you will be getting 3 minus lambda. So we will be getting something common. So we'll write operating this. Okay. Now let us write down. So we will get 3 minus lambda. Here minus 1 for this part, okay. Minus 1 plus this and plus this. Again, what will get? We get minus 2 plus 5 minus lambda, which will be 3 minus lambda. So here also we are getting 3 minus lambda. Here also 3 minus lambda. Okay. So minus 1 1, 5 minus lambda, minus 1 minus 1, 3 minus lambda. Okay. So from the first row, I'm getting 3 minus lambda, 1 1 1, minus 1, 5 minus lambda, minus 1 1 minus 1, 3 minus lambda. Now here you see that the first row has got all the elements 1. So we can easily make 2 of them 0 and then we can expand. Okay. So operating C2 tends to C2 minus C1, C3 tends to C3 minus C1. So here we'll get 3 minus lambda and C1 will remain as it is, and for C2 what we have to do? C2 minus C1, so 0, and here 6 minus lambda minus 2, 0, 0, and 2 minus lambda. Okay. Now I can expand along first row. So 3 minus lambda, and here 6 minus lambda, 0, minus 2, 2 minus lambda. Then 3 minus lambda, and here 6 minus lambda into 2 minus lambda minus 0. Okay. So 3 minus lambda, and here what we can do is we have to multiply. So 6 2s are 12 minus 6 lambda minus 2 lambda plus lambda square. So no need to expand. Why I'm expanding? No need to expand. Leave it. So 6 minus lambda, 2 minus lambda is your answer. Okay. So this was your value, but I think here in question they have put this whole thing as 0. Okay, so here this whole thing is 0. Okay, so no problem, this whole thing was 0, so I've taken this left hand side to be delta. So actually they were saying to here we have to evaluate the value for lambda. So delta we have found already, so this is not your answer. So we got our delta this much. Now as delta is equal to 0, therefore 3 minus lambda, 6 minus lambda, 2 minus lambda is equal to 0. This implies that 3 minus lambda 0, or this one is 0, or this one is 0. So lambda is 3 or lambda is 6 or lambda is 2. Therefore lambda equal to 2, 3, 6. Okay, so here lambda can have these values 2, 3, 6. So this was your question number 4. Okay children, so now question number 8. 8.1 will be your homework. In fact, all the questions from question 8 will be your homework. Okay, so you will try them, and if you get stuck somewhere you may ask me. Okay, but this will be your homework. I'm not giving you hint also. Okay, and maybe in the next class I'll give you the solution also, but first I want you all to try. Okay, so this is your question 1. I'm just scrolling it down slowly because maybe a few of you must not be having your textbook with you. That's why I wrote these questions. Question 3. This is question 4. This is your question 5. Okay. So 5, 4, 3, 2, 1, done. So this is all for today.